All right. Yes, star quality challenge. Ready, set, go. Here we go. L'Hopital's rule. Did him yesterday. Oh, wow. She was shopping for her mom. Yeah, very important stuff. I'm glad that we're able to accommodate all types of learners in our classroom. Yep, the gift of giving. All right, so here's L'Hopital's rule. If you're given the following condition, suppose that you have a limit of a function divided by another function. And as you go to find that limit, the top one goes to infinity and the bottom one goes to infinity. Or suppose the top one goes to negative infinity and the bottom one goes to negative infinity. Or suppose you get 0 divided by 0. These are what we call indeterminate forms. For my daughter last night, Daddy, she's 6 years old, Daddy, if I take infinity and I add 1 to it, don't I just get infinity and 1? I'm like, okay, this is heresy. How do my child speak this type of stuff? I mean, it's exactly. Infinity plus 1 is infinity, for crying out loud. She's treating it like it's a number. It's not a stinking number. Yeah, I did. I screamed at her. She cried. She went to bed. I said, good. No. Her 11-year-old sister spoke up and said, Kenley, infinity is not a number. You can't point to it on the number line. And so that's, I'm so proud. I'm just like, this is great. Like, your video recording. What? I'm not talking to you for the rest of the day. Caleb Milkowski just asked the worst question in the world. So, all right. Okay. All right. Yeah, whatever. So we got a Kalib. Kalib. Oh, she did? She loved it? What's your mom's name? Anne, right? Yeah, we're going to try to figure that out. Okay. So if you get an indeterminate form, then this is what we do. L'Hopital said this. He said, take the limit as x goes to a of f prime of x over g prime of x. What? Sweet. And that's equal to the limit. And I will make sense of it for you. Okay? Yeah. So I'm going to show you a couple examples, okay? Let's look at the limit as x goes to infinity of x squared over 3x. Now, don't do any algebra. Just allow this to kind of get into your brain so you can understand what's going on. If I plug in infinity and square it, I get infinity. If I take 3 times infinity, I still get infinity. So you get infinity over infinity. But if you were to graph these, and we graphed x squared, okay, you get something like that. And if you graph 3x, you get something like that, right? L'Hopital's rule says if you get infinity over infinity, we can see this function's headed towards infinity. We can see that the red function's headed towards infinity. It says check the rates at which they're going to infinity. So right now, they're pretty close to each other right here, aren't they? If you divide them, you get like 1. But as you move on to this direction, what's happening to the black function? Yeah, at a much greater rate, isn't it? And so if you take and you were to divide the black one by the red one, you'd keep coming up with bigger numbers, right? And for that reason, we can see that when we take the derivative of the top and get the limit as x goes to infinity of 2x over 3, well, you get, 2 times a very large number over 3, which is a very large number. I'm going to change it just a little bit. Suppose we had the limit as x goes to infinity of 2x over x. Now, obviously, that's going to be what? 2. But if you do plug in infinity, you get infinity over infinity, right? So if, again, I consider what's going on here, x looks like this, and 2x looks like this. I should probably just a little bit steeper. If you take the blue divided by the red, you can see that the blue has twice the height of the red, right? And here, the blue has twice the height of the red. And here, the blue has twice the height of the red. Even though they're both going towards infinity, if you take one divided by the other, you're going to get 2. This one is always twice as large as that one. So L'Hopital's rule says that in these situations, the derivatives help us come out with the values that we want. So here's a great example. Limit as x goes to 1 of natural log of x over 1 minus x. You don't even know what the graphs look like. I'll draw them real quick. We're not going to do this every time, but try to give you a little bit of an idea. Natural log of x, everybody knows that this passes through 1, 0 because you had a wonderful college algebra experience. And if you look at 1 minus x, you know that that graph looks like this because you've been doing that your entire lives. So that's graphically what we're trying to calculate. What is that limit? Well, let's plug in 1. What's the natural log of 1? That means e to what power is 1? E to the 0 power. So we get 0 on the top. And if I do 1 minus 1, I get 0. Well, that's an indeterminate form. I don't know what it is. How do we figure it out? Give up. No. L'Hopital. Do it. Limit as x goes to 1 of what's the natural log of x? Derivative. 1 over x. Good. What's the derivative of 1 minus x? -1. Sweet. Plug in 1, we get 1 over -1, which is -1. So K. Olive decided to invoke, instead of L'Hopital's rule, he liked to call it Little Hospital's rule, which is what every single calculus class does all the time. L Hospital, whatever. Yeah. L'Hopital. Hey, you got to stop and smell the roses every once in a while, folks. That's pretty cool. Is somebody talking because Adam Nelson doesn't exist today? That's awesome. How do you figure out that limit? Holy cow, it's -1. That's sweet. Let's do it. I don't hear anything. E to the infinity is? Infinity squared is? Oh no, I can't do infinity over infinity. Let me invoke L'Hopital. What do I get? E to the x over 2x. Do what it says, the derivative of e to the x is e to the x. Isn't that wonderful? So now I plug in infinity and I get? Oh no, it happened again. So do it again. Sure. Example 4. Natural log of 2x. I just showed you the graph of natural log. It heads off towards infinity at a very slow rate, but it definitely heads off there. So we get infinity. And then the cubed root of x, again, it's kind of like the square root of x. It heads off towards infinity. Not a very great rate, but it does go off towards infinity. And yeah, it's very, very enticing to just write 1, isn't it? but you understand that that is heresy. Okay? So the limit as x goes to infinity of, we have to take the derivative of the top. Chain rule. So I got the natural log of u, and I got 2x, derivative 2x, derivative natural log of u, 1 over u. So I get 1 over x. Because the 2's cancel. And what about that cubed root of x? That's x to the 1/3. What's the derivative of x to the 1/3? Sweet. I should probably simplify that, huh? So it looks like I end up with the limit as x goes to infinity of, so I end up with a 3 in the numerator. Oh, it's a 1. Okay. So I got a 3x to the 2/3 in the numerator. And if you take x to the 2/3 and divide it by x, you get x to the 1/3 in the denominator. Okay, so I plug in infinity. I get 3 in the numerator. In the denominator, you get. So what's 3 over a super big number? 0. Look at example 5. What do you want to do with that 1? Plug it in, right? What's the natural log of 1? 0 squared? 0. Then the denominator is cosine of pi x. Pi times 1 is pi. Cosine of pi? -1, right? So you get -1 in the denominator. Is that an indeterminate number? It's not indeterminate, is it? What's 0 over -1? 0. No need for L'Hopital. Yeah. French mathematician. Against his rule? I'm not that smart. I don't have my PhD, guys. I got a master's. It's not even math, so I'm pretty low on the totem pole for mathematicians in the world, believe it or not. It's not in math. I got a master's degree in the science of education with an emphasis in mathematics. In order to get my master's in math, I probably have to have 7 or 8 graduate courses in math. I've only got 4. 4.5. So I'm a weakling. If I chose to pursue a master's in mathematics, I should probably stop teaching for a year or 2 and really dedicate full time to it. So, and what would I do with it? No, you want to be a professor, you need to get your PhD. You need to get your doctorate. No, I like teaching you guys. I don't want to teach college kids. They sit there and, yeah, they're snots. College kids are snots. You guys are all going to be snots next year. No, I think you guys are an exciting time of your life. You're making choices about what to do, and you're fun, and I like that. All right. Okay. Yes, I like watching you shop for your parents in the middle of class. Okay, so this should be, I wrote this problem incorrectly. It should be a 1 plus cosine of x instead of 1 minus cosine. Sorry. So, sine of pi, 0. Cosine of pi, -1. So 1 plus -1 gives me 0. So I do have an indeterminate form. We don't know what this result is. So I have to apply L'Hopital's rule. I've got the limit as x goes to pi of, what's the derivative sine of x? We've got cosine of x over negative sine of x. Now I plug in pi. What's cosine of pi? Sine of pi? Uh-oh. Is that indeterminate? If you get 1 over 0, so you say it's undefined, you're correct as a value it's undefined, but as a limit we may be able to ascribe more to it. And I'll show you how that works. This is the most confusing part of the day. If you make it through this, you're totally good. In blue, I'm going to graph negative sine. Period of 2 pi. Pi is right here. Whoop. Something like that. And the cosine graph are we okay with those two graphs? So I want to take cosine and divide it by negative sine as x approaches pi. I have to approach from the right and from the left. So I'm going to approach from the right. Let's grab our cosine values. As I approach from the right, what's the cosine value going towards? Negative 1. So I have negative 1 divided by, and then if you look at the sine graph, as you get really close to pi, but just stay on the right-hand side of it, is the value positive or negative? It's positive, isn't it? So it's a really small positive number. I'll do little n for really small positive number. If you take negative 1 and divide it by a really small positive number, say like negative 1 divided by 1/1000th, what are you going to get? Negative big number. This is going to go towards negative infinity. Now, let's approach from the left. Okay, as I approach from the left, where's the cosine graph going? Still negative 1. And then the sine graph from the left is still a very small number, isn't it? But it's a very small negative number. If you take negative 1 and divide by a really small negative number, you're going to get a very big positive number. So from the left, it goes to positive infinity. From the right, it goes to negative infinity. So therefore, the limit, amen, does not exist. Way to go. So that's a graphical argument. You could also write this as cotangent, but I was just afraid you guys didn't remember what the graph cotangent looked like. So I pulled out sine and cosine. No, one was positive infinity. Oh, yes, yes, exactly. And we're going to see that example with 8. Okay, number 7. I plug in 1. What do you get? 0 over 0. Uh-oh. L'Hopital to the rescue. Derivative of 14x to the 5th. Divided by? Can you plug in 1 now? What do you get? 70 over 24, or 35 over 12. Sweet. That's the limit. Which is really cool. Like, I actually, if you graph those on the calculator, if you graph this function, this is very close to 3, but it comes out to be exactly 35 over 12, so it's pretty neat. Okay, last one. Plug in 0. T goes to 0, not x. So t goes to 0, so e to the 0 is 1 minus 1 is 0, and then 0 to the third is 0. I get 0 over 0. What do? L'Hopital. Limit as t goes to 0 of, what's the derivative of e to the t minus 1? E to the t. What's the derivative of t to the third? 3t squared. And so I plug in 0, and I get, no, e to the 0 is 1 over 0. Uh-oh. Does L'Hopital's rule apply here? No. So let's consider the graphs. What does e to the t look like? Remember what your exponential function looks like? That's logarithm. E to the t looks like this. And it passes through 0, 1. What does 3t squared look like? Quadratic, right? So check it out. I'm going to approach from the right. What is e to the t approaching? 1. What is happening to the quadratic? Yes, it's becoming a very small number, right? Positive or negative? What's 1 over a very small positive number? No, that's going to go to infinity. Go from the other direction. What is e to the t going towards? And what's the other one going towards? Really small positive, which is? So the limit is infinity. Boom. I'll put the assignment up when you get back. No, different. Or it might be the same. I can't remember.